So we're given this function right here, asked to estimate its two zeros using Newton's method, starting with x sub 0 equals -1 and x sub 0 equals 1. We're going to see that this doesn't work in a subsequent board. We're going to let x sub 0 actually equal 2. Have a brief discussion on why Newton's method works and where it comes from. We're going to find the equation of the tangent line to the point on f of x where x equals -1. That's for the first root on the left, which is this -1.87552 approximately. And then we're going to find out where that tangent line intersects the x-axis. So x sub 0 equals -1. F of x sub 0 is -14. That's this point right here. We're going to write the equation of the tangent line to the graph at that point. The slope of that line is f prime of -1, which is -7. Okay, so if I write the equation of that tangent line using point slope, y minus f of x sub 0 equals the slope times the quantity x minus x sub 0. If I substitute in the values that I know, y plus 14 equals the slope is -7 times x minus a -1. To find this point of intersection right here along the x-axis, I want to know what does x equal when y equals 0. So when y equals 0, if I divide both sides by -7 and then subtract 1, there's where that -3 comes from. So this is the point, the x-coordinate of the point of intersection with the tangent line to the point where x sub 0 equals -1. And just up here, we can show you where Newton's method comes from. Here was the y value, which is 0. This is the equation of the tangent line in point slope form, but I'm letting y equal 0. If I divide both sides by f prime of x sub 0, I get this term right here. And then add x sub 0 to both sides. This is what I get. So Newton's method is really just finding the x-coordinate of the point of intersection with the tangent line to the graph at the given point where x equals x sub 0, or in this case, -1. And now what happens is we're going to use this value to create another point on the graph. And that's what we're going to show on board 2. So here's the point where x on the graph where x equals -3, which was the x sub 1 that we found. If we find the tangent line at that point, we're going to use Newton's method right there. This is f prime. That's the slope of that tangent line. This is the y coordinate. I already did x sub 1. So x sub 2 is f of -3, which is 72, over f prime, very steep, -111. And where that point, where that tangent line intersects the x-axis, what we hope you see is that this point is getting closer and closer to the true root. If we find the point on the graph that has this x-coordinate, it'll be up in here somewhere, and the tangent line will go like this, and it's going to get even closer to the -2. And we can keep iterating until on a computer this value starts repeating itself. Okay, so here's x sub 2 based on these numbers right here, -2.35. Okay, we're going to see on boards 4 and 5, or on board 5, that Newton's method gives us even better approximation. On board 3, we're going to show you why x sub 0 does not work. Okay, and the reason is, if I write the equation of that tangent line, it intersects the x-axis way out here at 21. In other words, it doesn't get close to this root. We need something that goes more like this. So that this x-coordinate gets closer to the real root. And the subsequent tangent lines get us closer and closer to that real root. So on the next board, we're going to let x sub 0 equal 2 and see the difference. So when x sub 0 equals 2, using Newton's method, there's the x sub 0. F of 2 is -8. F prime of 2 is 29. That gives us this 2.275, which is that point where the tangent line intersects the x-axis. And then if I use that point on the graph, the x-coordinate on the graph, and write another tangent line, it'll even get closer. And that's what this is right here, 2.235. And finally, if I iteratively use Newton's method until these decimals start repeating, you can see I get closer and closer to the roots that are given on Desmos graphing calculator. Okay, there you go. Hope that helped. If you have any questions, post a comment.